Hello, let's look at transformers. So a transformer is a device which basically steps up or steps down voltage. So by stepping up, we mean that it receives a low voltage and then it outputs a higher voltage. Then stepping down means that it receives a higher voltage and then it outputs a lower voltage. So a transformer that steps up voltage is what we call a step-up transformer, and the one that steps down voltage is what we call a step-down transformer. So for a step-up transformer, it has more turns in the secondary coil, so meaning that it has fewer turns in the primary and then more turns in the secondary. Well, a step-down transformer, for it, it has more turns in the primary and fewer turns in the secondary. So if you have to look at how and what makes up a transformer, so a transformer is made up basically of a soft laminated iron core, which is always this, and then wires are wound around, or what you call coils are wound around these other sides of the soft laminated iron core. So on this side where a source of alternating current is connected, that side is called the primary coil. So on the coil where the coil which is connected to a source of AC is what we call a primary coil. And then the coil which is connected to an output is what we call a secondary coil. So basically, since current is supplied in the primary coil or an EMF is supplied in the primary coil, there is a changing magnetic field in the primary coil which causes a voltage to be induced in the secondary coil. So that's how voltage appears in the secondary coil, yet there is a supply of current in the primary coil, and the process is what we call mutual induction. So let's look at what basically a transformer is. So basically, this is the iron core that composes the transformer. So coils are connected at these sides of the iron core. So one coil which is connected to the source of AC, this side, that coil is called the primary coil. And then the coil which is connected to the output, this one here, is what we call the secondary coil, as you can see. So the two coils are well insulated from each other and do not come into contact with each other. So meaning that there is induction which causes voltage into the secondary coil. So transformers can be step up or step down. So a step down transformer, the number of turns in the primary is greater than the number of turns in the secondary coil. As you can see here, though the turns in the primary are greater than the turns in the secondary. Then in a step-up transformer, the number of turns in the secondary coil greater than the number of turns in the primary coil, as you can see. So that is what we call a step-up transformer. Number of turns in the secondary is greater than the number of turns in the primary coil. So that is basically what a transformer is, and that is what it is all about. So if you look at the mode of operation, so an alternating voltage is applied in the primary coil and it creates a changing magnetic field which links the secondary coil. So meaning that the secondary coil will get an induced EMF in it due to the changing magnetic field caused by the primary coil. So therefore, if the number of turns in the primary coil, is NP, and then the EMF or the alternating voltage in the primary coil is VP, and then the number of turns in the secondary coil is NS, then we don't know which voltage will be induced in the secondary coil. So basically we use the equation VS out of VP equaling to NS out of NP to calculate what could be missing or to calculate the voltage which is induced in the secondary coil, because it is the only one which is missing. We know the number of turns in the primary, we know the voltage supplied in the primary, we also know the number of turns in the secondary, and we can use this equation here to find the voltage which is induced in the secondary coil. So basically this equation here is what we shall always be using. Okay, so there are energy losses that occur in a transformer, and these are basically, the first one is energy is lost due to resistance of the copper wires which are used to make the coils. So to reduce this effect, we use wires which have a very low resistance. Then the second way in which energy is lost is by eddy currents. So since there is magnetization or magnetizing which is taking place, so in that process, some energy is lost, and that can be minimized by laminating the core. So basically, eddy currents are basically due to the changes in the magnetic fields. Then we have what we call hysteresis loss. And for this, of course, there is what we call the magnetizing force, and then there is the induced magnetism. So if the two don't occur, or if the two occur at different rates, then there is some energy which is lost due to hysteresis. And this can be minimized by using a soft iron core or soft magnetic materials. Then there is also energy loss due to poor flux linkage between the primary coil and the secondary coil. So this can be minimized by ensuring that the primary flux is linked with the secondary flux very well. So transformers always have energy losses which are very low. That is, they lose energy at a very, very, very low rate. So energy losses are very small, but most transformers, they have a very low energy loss. So if the input power is equivalent to the output power, then we say that the transformer is 100% efficient. So in that case, it means that the power which is put in the primary coil is the same power which is out of the secondary coil, since the secondary coil has the output. So if you have to use the equations of power, because power in itself is given by IV. So the power in the primary coil is IP, VP. I is current in the primary, and VP is the EMF in the primary. So this should be equal to the current in the secondary multiplied by the EMF in the secondary coil. So this relation here can be used to compare the power in the primary coil and the power in the secondary coil.